This is a train that can cross an entire country before lunch. Not a metaphor. A literal high-speed rail line so fast it can shrink a 12-hour drive into 90 minutes. And right now, three regions are locked in a race to build the most ambitious rail networks the world has ever seen. The strange part? The country most people assume is winning might actually be falling behind. Let's get into it. High-speed rail sounds like a simple idea. Bigger engines, straighter tracks, faster trains. But building a network capable of moving hundreds of millions of people at 300 kilometers an hour is one of the most expensive, most politically fraught forms of infrastructure on Earth. And right now, three very different approaches are being tested in real time. To understand how we got here, we have to rewind about 60 years. In 1964, Japan opened the Tokaido Shinkansen, connecting Tokyo and Osaka in under 4 hours. At the time, it wasn't just impressive, it was borderline unbelievable. Trains simply didn't move that fast, not reliably, not at scale. For nearly 2 decades, Japan had the concept almost entirely to itself. Then, Europe caught on. France launched its TGV network in the early 1980s, prioritizing dedicated high-speed corridors between major cities. Germany followed with the ICE. Spain, despite a smaller population, ended up building one of the most extensive networks on the continent, in part because its cities are spread out just far enough to make flying inconvenient and driving exhausting. But the real disruption came later, and it came from a country that, as recently as the early 2000s, had almost no high-speed rail at all. China's first true high-speed line opened in 2008, just in time for the Beijing Olympics. What happened next is one of the fastest infrastructure buildouts in human history. Within 15 years, China had constructed more high-speed rail than the rest of the world combined. As of last year, the network stretches beyond 45,000 kilometers, connecting cities that a generation ago were a full day's journey apart by road. To put that in perspective, that's enough track to circle the Earth more than once, and it's still growing. So why does this matter now, in 2026? Because the countries that once defined this technology are suddenly scrambling to keep pace, while newer entrants are trying to leapfrog the whole conversation entirely. Let's start with the United States, because the American story here is, frankly, a cautionary tale. California's high-speed rail project was approved by voters back in 2008 with an original budget of roughly $33 billion and a promised completion date in the early 2020s. Today, current estimates put the cost above $100 billion, and the only section under active construction is a stretch through the Central Valley, nowhere near the original vision connecting Los Angeles to San Francisco. What went wrong wasn't the engineering, it was everything around it. Land acquisition disputes, environmental review processes that can take years per segment, local political opposition, and a funding model that relies on a patchwork of state and federal dollars rather than one committed pot of money. Every changed administration brings the risk of paused funding or renegotiated priorities. Contrast that with China, where land can be acquired and cleared at a pace that would be unthinkable in a country with robust private property litigation. A rail corridor that might take a decade of environmental review and legal battles elsewhere can go from announcement to operation in under 5 years. That's not necessarily a point in China's favor from a governance standpoint, but it's undeniably a point in China's favor from a construction speed standpoint. Meanwhile, Europe sits somewhere in the middle. The continent has decades of high-speed rail experience and genuinely excellent existing networks, but expansion has slowed. Cross-border projects like the long-delayed rail tunnel connecting France and Italy under the Alps have faced budget overruns stretching into the tens of billions of euros, and construction timelines pushed back by years. The engineering challenge of boring through mountain ranges is difficult enough without added layers of multinational bureaucracy, where each participating country has its own approval process, its own contractors, and its own political calendar. And yet, Europe still has one major advantage: Density. Its cities are close enough together and its existing rail infrastructure mature enough that even incremental upgrades produce outsized benefits for travelers. Before we get further into the numbers, let's talk about why any of this actually matters beyond bragging rights. High-speed rail isn't just about shaving an hour off a business trip. It fundamentally reshapes how a country's economy is distributed. When you can get from a mid-sized city to a major economic hub in under 2 hours, that mid-sized city stops being a satellite and starts being a viable place to live, work, and build a business. Property values shift, companies decentralize, labor markets stretch across what used to be impractical commuting distances. China has leaned into this deliberately. Planners have used high-speed rail as a tool to spread economic activity away from a handful of megacities and into secondary and tertiary cities that previously struggled to attract investment. It's infrastructure as economic policy, not just transportation. Now back to the race itself. There's a fourth contender worth mentioning, and it's one most people don't immediately think of: India. India's rail network is enormous by sheer ridership. It moves more passengers daily than almost anywhere on Earth, but none of it, until recently, qualified as true high speed. That's changing. A dedicated high-speed corridor connecting two major economic centers is currently under construction, using technology licensed and adapted from Japan's decades of Shinkansen expertise. It's a smaller, more targeted approach than China's blanket buildout. Prove the model works on one heavily trafficked corridor before expanding further. It's a strategy that mirrors what Japan itself did back in 1964. Start with a single, high-value connection, let it prove itself financially and operationally, then expand once public and political confidence is established. So here's the actual question underneath all of this. Does high-speed rail even make financial sense, or is it a prestige project dressed up as infrastructure? The honest answer is, it depends enormously on the country. Japan's Shinkansen network is remarkably profitable, not just breaking even, but generating enough revenue to fund maintenance, upgrades, and even help subsidize other parts of the national rail system. That's the exception, not the rule. It works because Japan's population density along the core corridors is extraordinarily high, and because decades of ridership have allowed the operators to fine-tune pricing, scheduling, and capacity. China's network, by contrast, is a mixed bag. The busiest corridors, these ones connecting major economic centers, are genuinely profitable and heavily used. But a significant number of the newer, more remote lines built as part of the national expansion strategy operate at a loss, sometimes a substantial one. Estimates suggest the state rail operator carries debt in the hundreds of billions of dollars, much of it tied to these less trafficked routes. The government's calculation seems to be that the long-term economic development benefits outweigh the direct financial losses. Whether that bet pays off over the coming decades is still an open question. Europe's networks vary line by line, with the busiest routes, think Paris to Lyon or Madrid to Barcelona, turning healthy profits, while newer or cross-border expansions often require ongoing public subsidy to stay viable. And that brings us to the engineering side, because building track that trains can safely travel at 300 plus kilometers an hour on is nothing like laying conventional rail. The curves have to be extraordinarily gentle, far gentler than a standard freight or commuter line, because at high speed, even a slight curve creates lateral forces that are uncomfortable or unsafe for passengers. That means high-speed corridors often require entirely new alignments rather than upgrades to existing track, which is part of why they're so expensive. You're not improving a railway, you're building an entirely new one from scratch, often elevated on viaducts to avoid uneven terrain and to keep the gradient as flat and straight across varied terrain. It's a higher upfront cost that pays off in construction speed and long-term reliability. Track itself also have to be built to far tighter tolerances. Rail joints, the gaps where sections of track meet, are largely eliminated in favor of continuously welded rail, because even a tiny gap becomes a violent jolt at high speed. The ballast, the crushed stone bed that conventional rail sits on, is often replaced entirely with rigid concrete slab track, which holds its shape far more precisely over time and requires less maintenance, at the cost of being significantly more expensive to install initially. Then there's electrification. Every meter of a high-speed line needs overhead power infrastructure capable of delivering enormous, consistent electrical loads, along with signaling systems sensitive enough to manage trains traveling the length of several football fields every few seconds, with braking distances measured in kilometers rather than meters. All of which is to say, the 60-year gap between Japan's first Shinkansen and today's global rail race isn't really about one big invention. It's about incremental refinement at a level of precision most passengers never think about while staring out the window at the scenery blurring past. So who's actually winning this race? By sheer scale, it's not close. China has built more high-speed rail in the last 2 decades than the rest of the planet combined, and shows no sign of slowing its expansion. By profitability and efficiency, Japan remains the gold standard, a network so well-tuned it essentially subsidizes